All right, let's get right to it right now. Find all the numbers disappeared. Find all numbers disappeared in an array. Okay, whoever the fuck made this title needs help. Yeah. All right, given an array nums of n integers where nums I is in the range of 1 to n. Nums I is in the range of 1 to n. Return an array of all. There does not appear nums. Okay, cool. Okay. One to n. So what is n first? What is n? Alright, and y in certain cases n equals nums.length. Okay, so that's a constraint. That's n. Okay, so 1 to n is the range. Next, it's going to be items that do not appear. 1 to n. Okay. So n is nums.length. Right, so we're going to count up. And that's why, when you look at this array, 1, 1, nums.length is 2. This is 2 elements, so that means it counts up to 2, which means 2 is missing. It's inclusive to n. So what I'm going to do here, given an array nums is thing, return an array. So I'm going to create an array called stores. It's my favorite name, the classic stores. Then I go for I in range. Now we just use the range they give us. So 1, it's inclusive, but the end limit is non-inclusive. So you have to go n plus 1. Because n plus 1, whatever is on this is n, it's going to be minus 1. So if I put n, it's going to be n minus 1. So if I put n plus 1, minus 1 equals n. So now it goes up to n, inclusive. This is how you make it inclusive to n. You have to add an extra 1. Because in Python, when you use the range function, the end limit goes minus 1 of that limit. So if I want to get n, I have to go n plus 1 to get n. If I want to get less than n, I just put n in on its own, and I get n minus 1 from this range. Okay, so next is going to be no, I'm not a beatboxer. I'm just a magician. JK, I'm a mage. I'm trying to get 99 software levels. Okay, so for I, so now I can be my actual numbers. So if what do I want to do? N log n. I don't want to get an n squared times. So what I'm going to do is I'm just going to sort it pre, because n log n is better than n squared. So if I go in, it's going to look through all the elements of the array for each thing. So it's basically doing a double for loop. So I want to reduce my time complexity. So I'm just going to go nums.sort, because it doesn't hurt to sort it. N is len nums. Let's see what's in here. 1, 2, 3, 4, 5, 6, 7, 8. 8. The length is 8. Oh, because I'm not counting on array elements. Ah, that's the thing. Right now I'm counting to the range, and I have to have a separate iterator for the array elements. So all I have to do is this. I'm gonna call this L equals 0. If I is 1, because right now I'm sorting the array and I'm going up in integers, but I have to compare it to something as I go up, right? But I can't do that with the array because it's going to go overflow, because I'm going to n plus 1, and I can't do that on this array. So what I'm going to do with the array is I'm just going to increment it from 0 to n. This is going from 1 to n plus 1, so 1 to n plus 1. This is going to 0, so 1 to n. This is going to 0 to n minus 1, right? So it's just going to be shifted by 1. So what I'm going to do now is if I equals nums at element 0, so I just have to say this, then oh no, if I is equal to it, skip, else append. So, and in any case, I'm just going to keep incrementing to see what else is missing. So I is always going to keep increasing from 1 onwards, and then if this element is not in the array and it's not matching I incrementing, then I want to add it to my stores. So it's going to be stores dot append stores dot append I. Else, so, and in any case I want to just increment L to go with it. That way it goes to the end of the array. Until it hits n. And then once I have all the added items, I'm going to return the stores array, which has all the missing elements. So I'm going to run that. Should pass. What is going on? 3, 4. If I is not equal to nums L, so 1. So for example, if I sort this, so 1, 2, 3, 3, 4. Okay, so 3, 4. Actually, you know what? Let's just do it the easy way. Let's delete all this logic. I just want to solve it at this point. So if I not in nums, stores.append I. That's it. That's all I have to do. Let's just do it easy. There's no point in making it hard for ourselves. I just wanted to see if I could reduce time complexity, but it's like there's too much BS with this question. It's not worth. See, look, this is where the time complexity comes in. You see that? It's taking forever. This is if you have like a million elements. Time limit exceeded. See, I knew exactly why this would happen. This is gonna happen to me. Okay. Okay, so there's another way we can do this. There's another way we can do this. It goes 30 out of 34 test cases. It did this on purpose because it wants us to save on time complexity somehow. Let's do this. Let's do this. What I can do is reduce the elements in there by creating a set and then create it into a list again. So I can go nums. All right, let's go back. I just want to see if this will work. I'm just curious. There's nothing wrong with being curious. Nums is the original array. Right, so what I'm going to do is I'm going to go temp equals set nums. So this deletes all of the duplicates now. The next thing I'm going to do is turn it back to a list, sort it, oh, you know what we could do? You know what we could do? I could take the set. So for example, if I go using AND operator with two sets, AND or union so I could just create all the elements. I could create all the elements and AND them. That's what I could do. Because they'll be all unique elements, and I just have to AND whatever. So let's say AND operator for inclusion to check Python to check the numbers in both sets. Check if element is in two lists at the same time. So what I'm going to do is I'm going to build a whole set. This is going to be temp. It's my list set. So I eliminate all duplicates. I'm going to go, I don't have to order it. Then I'm going to go for I for 1 to n plus 1. And let's just build I out. So this is going to be O of n time anyways. Let's set deletes everything O of n time. So stores. So this is going to be all nums. I'm going to call this all numbers. The next thing is going to be what is next one going to be? Okay, so first get my temp, get my set, get this. So we have two lists, all nums and stores. Now I want to go and test if list share. So this is going to be set A and set B. So check intersection of sets Python. Python. Oh, my throat is killing me. It's my kickboxing and I got my ass whooped. So what I do when I take an ass whooping is I just eat a lot of protein and hopefully I just end up recovering faster. That's my bro science method to recovery. Just so you guys know, I am human. Set intersection method contains items that exist in both X and Y. Apple. How do you get the inverse of set intersection? Set intersection Python and inverse. Opposite of set intersection. Best way to find Python set. Set intersection. Difference and symmetric difference. Okay, so difference 806. 806 24 24 intersects at 24. It's pretty much the opposite of intersects. Intersects is everything that does match. Can you do not? I'm curious. Let's try it on Python Playground. Python Playground. I believe this is the way to solve it though. So what I'm going to do is print y. So it's going to be set. Two, 4, 6, 8, 1, 3, 5, 7. So 2, 4, 6, 8. Then I'm gonna go 1, 3, and then 5, 7. I'm gonna do here. So then it's gonna be z equals 1, 3, 5, 7, 9. So set set1 equals list of set x, or I'm just going to call it set x. Set2 equals set y. Now set z. Okay, so set1 and set2. So then I'm going to print set1, print set2. So I want to observe what's going on first. So you have these two sets. Then I want to print I'm just thinking. Okay, so I got set 2, 1, 2, 3. Okay, so set 1 and set 2. So this is where we find intersecting things. So 1, 3. What if I had 7? 1, 3. I don't have 5 here, so let's try the 7. I just want to see if it holds true. 1, 3, 7. Do you see? It doesn't matter if they're in sequence or not. It skips 5. So this gives you everything that's common between that. So let's try. Does that work? Inverse of intersection and Python. Symmetric underscore difference is the opposite to the set intersection. Okay, symmetric difference. Set 1 dot symmetric difference. Set 2. Okay, so let's try that. Okay, so set 1, set 2. I have this 1, 3, 5, 7. Print set 1, or no, set 2 dot symmetric underscore difference. Set 1. Does that work? What is different? So it's set 2 versus set 1 symmetric difference is the inverse of this. So 1, 3, 5, 7 are common elements. 2, 4, 5 Okay, set 2 does not have 2, 4. It has 5. Oh no, it doesn't have 5. Over and squared. So I have symmetric difference is the intersection of a set. Opposite to Python's set intersection method. So for example, set 1, 2. So 2, 4, 5, 6. So set 1, symmetric difference set 2 is going to be 2. So 4, 5, 6. So 4, 6 would be the intersection. This one would be 2, 5, 7, 8. Okay, this is what's happening. Two, 5, 7, 8. In this case, if you have everything, so let's do this. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 5. So let's check symmetric difference. Let's try and modify this till we get it. So 2, 4, 6, 8, 9. So 2 doesn't have it, 4 doesn't have it, 6 doesn't have it, 8 doesn't have it, 9 doesn't have it. Okay, so this is the way to do it. If you have one array that contains everything, if you use set 2, symmetric difference from set 1, it tells you everything that the first set doesn't have. So set 1 has everything, right? So it tells you everything this set doesn't have. So what I'm going to do here is I'm going to modify this array. So I'm going to create my temp stores. It's going to be list set. So I'm just going to go set nums. Then I'm going to go all nums. All nums.append I. So now it has everything. And then I'm going to return the temp. So everything that's missing. So temp dot symmetric. How do you spell symmetric difference again? Symmetric difference. Okay, so 2 M's. Symmetric difference underscore difference, symmetric underscore difference, and then I'm going to go all nums. Same way we did it here. So set 1 has everything 1 to 8. This set 2 is what we're comparing the original set to see what's missing. So symmetric difference will pretty much show you what is missing between the two. So but the only flaw in symmetric difference is if there's numbers missing in both, it's going to show what's missing in both from each. Right, so you have to make sure one of the arrays has everything. So we only see what's missing in this target one. So if that's true, then all we have to do is this. We just return temp dot symmetric difference all nums. Oh, but this returns a set. So I have to go list. I have to turn this into a list at the end. all nums is going to be let's just make it a set here. Let's just make it a set and then go dot add. So then I just add it. Then I go, oh wait, symmetric difference. Do I have to do sets? Yeah, it should be with sets just to make it consistent. Set versus set. I could get the symmetric difference and then I turn it into a list because it says return an array. So I'm going to return list. That should work. That should work. And that should be it. Please don't be a time limit. Yes, 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 yes. See what we did? See what we did? We ended up creating a solution that worked, but the time complexity didn't work. So we're like, okay, my next step is, okay, there's got to be some way to check if both elements occur at the same place. So one of the ways in one of the previous Leetcodes we did, they used the AND operator between to find the intersection of sets. So my thought process is if we can do that, then there should be something that's the opposite of that. So the inverse of the intersection of sets, which is symmetric difference. If I have everything in one array and patches in another array, it's going to give me everything that's missing in this patched array temp. And that's what I did. I construct the array with everything so I could produce the output of only the missing elements. And beats 56.17% of other solutions. So if you like this video, please give it a thumbs up, subscribe, comment below. Knologist out.